All right, there is one sort of quirky, cool thing that I like to show you about these negative bases, all right? Now, if you had noticed, every single exponent that I had used, whether it was a 2 or a 4 or a 6, those were all even exponents, okay? And I chose them on purpose. Even exponents are going to, let's say, let's bring this back. 4 is an even exponent, okay? Do you see that it really matters whether this parentheses is here or not, okay? Because if this parentheses is here, then I'm multiplying a negative number, in this case negative 2, times itself an even number of times, in this case 4 times. And so whatever results, I don't even need to do the actual computations of what 2 times 2 times 2 times 2 is. It doesn't even matter. I automatically know that whatever this evaluates to is going to be something that is going to be positive. How do I know that? Because I know that if I have an even number of negatives that are being multiplied, it will eventually turn out to be a positive number. Now, I would actually have to multiply what 2 times 2 times 2 times 2 is to figure out what the quantity is. But in order to find what the sign is, all I got to do is figure out, is this going to be an odd or an even exponent? And if it's an even exponent, it's going to be a positive result. All right? Now, which means that it's very important that if I want to use this entire negative 2 as a base, I'm going to have to put it all in parentheses. Because if I don't put it in parentheses, I'm going to wind up with a negative 16 for the reasons that we went over in the past video. All right? Now, here's the thing. If I ask you to evaluate an expression that has an odd exponent, it turns out that even if you don't do the intermediary steps of expanding it correctly, you'll end up getting the same evaluated answer. Let me show you how. Okay, let's say now we're going to do not a even exponent now, but let's do an odd exponent, all right? So now we have negative 2 to the third power. 3 is an odd number. And here is negative 2 to the third power. Here there's no parentheses. Here there is a parentheses. If we do both of these perfectly, we're going to come out to the actual same evaluation at the end. So here, but let me just add that the way that we get to our ultimate answer is going to look different, all right? So here, if I were to use proper form, all right, this is entire base. This negative 2 is the base. So this is negative 2 times negative 2 times negative 2. All right, so 2 times 2 is 4 times 2 is 8. And then a negative times a negative is a positive, and a positive times a negative is a negative, ultimately. So here, it evaluates to negative 8. Even though I did everything perfectly great, turns out to be a negative answer. And that's fine, because this is an odd exponent. Let's do this over here. If I were to use proper form, I could say this is like a negative 1 times 2 times 2 times 2. All right, so this would be negative 1 times 2 times 2 times 2 is 8. So it's negative 1 times 8 or negative 8. It comes out to be the same evaluated answer of a negative 8. And it's because we have an odd exponent here. However, I do want to caution you, yes, while the evaluated answer happens to be the same because there is an odd exponent, the way that we came to that answer are going to be very different.